Good day. In today's lecture, we go to Chapter 6, Control Statements. There are no videos or notes for Chapter 5 since Chapter 5 is just how to use the C compiler, how to open the C editor, save the file, and run. 6.1 Branching operation, if-else statement. If there is only one condition, so the syntax is going to be if expression in bracket is true, execute the statement or statements. If you have multiple statements, then the statements must be compounded. You have to group them in one compound statement using the curly brackets. When there are two options, use the if expression is true, execute statement 1, else execute statement 2. When there are more than two options, use the if else clause. If expression 1 is true, execute statement 1, else if expression 2 is true, execute statement 2. For the last option, it's always else. Execute statement n. Of course, when you have n number of conditions or options. Let's go to this example. So your test 1 is going to be very similar to this example. So read mark in the range of 0 to 100 from the keyboard and assign the following grades to the mark. Let's call the mark as the variable to keep the variable mark entered from the keyboard float, because mark can have decimal points. So scanf mark, don't forget the ampersand there for scanf in front of the variable name. Mark is float, so that's why the format is going to be %f. The first condition is if mark is greater than or equal to 80, the grade is A. Else if the second condition, if this is false, we go to the next condition, which is if mark is greater than or equal to 70, and mark is less than 80, grade is B. If this is also false, we go to the third condition. Else if mark is greater than or equal to 60 and mark is less than 70, grade is C. If all of these are false, then the last condition must be true. You don't have to test. Else if mark is less than 60. If these are false, definitely mark is less than 60. So for the last condition, you just use else. So the grade is going to be F. So you can run this program. In this example, I just put on the, from the keyboard 79.99 as the mark, and the process grade is going to be B. You cannot get A in this case. Of course, to get A, it has to be exactly 80 or more. 6.2 Looping operation. First up, the while statement. While expression in bracket is true, it has a non-zero value. Remember, true is 1, integer 1, false is integer 0. Execute this statement or statements. Example, display consecutive digits 0, 1, 2, up to 9 with one digit on each line. In other words, I want to have 0, 1, 2, 3, up to 9. Let's call the variable to keep all these numbers digit. So initial value, let's 0. So for this integer digit, of course, while this is true, execute these two statements. First up, digit is 0, so this is true. So printf digit, so you get on the screen 0. /n mean after printing 0, it goes down to a new line. Now we increment digit by 1. You cannot exit the loop from here. You can only exit the loop if this is false. So from the last statement here, you must go back here. Check the condition. If this is true, printf digit, keep on repeating the process. After printing 9, the last digit is 9, digit is 10. From here, you go here, this is false, so out of the loop. That's how you exit the loop. This statement can be written as, in compact form, as digit plus plus or plus plus digit. This same program can be concisely written as follows, where we can combine these two into one operation. Printf digit, the post operation is going to be increment digit by 1, which is this line. Of course, in this case, post will produce this same output on the screen. 6.3, the do while statement. In the while statement, we test first. In the do while statement, the test is last. The test comes later. So, do this statement, execute this statement, while expression in bracket is true. Let's go back, same example. Do all this while digit is less than or equal to 9. First up, digit is 0. There's no test. You just print digit is 0. After that, increment digit by 1. Then comes the test. If this is false, out of the loop. If this is true, you must go back to the first statement in the loop. So this is true. You must go back here, first statement, printf digit, increment digit, test, true, go back here again, increment digit, false, then out of the loop. This will also give the same results as the while loop. Finally, the for statement, looping operation using the for statement. In C, this is the most commonly used looping statement, the for statement. So the syntax is going to be for expression 1, expression 2, expression 3, separated by semicolons. So what happened? You enter the loop, expression 1. From here, you must go here, expression 2. If this is true, execute all the statement. From the last statement, you must go to expression 3. From expression 3, go back, expression 2. True. So you keep on looping. Yeah? Until expression 2 is false. If expression 2 is false, then out of the loop. Let's go back to the same example as before. You enter the loop here, digit is 0. Go back here, expression 2. It's going to be true. True, follow the blue arrow. Execute this statement. Printf digit. From here, you must go to expression 3. Increment digit. Check again. True, keep on looping. So we're going to display digit 0 to 9. After displaying 9, what happened? You go here, digit is going to be 10. Follow the arrow. 10 less than or equal to 9 is false. False. Follow the red arrow out of the loop. Finally, nested control structures. This is basically multiple for loops. For example, generate this multiplication table. 1 times 1 is 1. 2 times 1 is 2. 3 times 1 is 3. Up to 12 by 12 is 144. So this is the loop. Let's say the first column is going to be J. second column is going to be I. Of course, the product is I times j. So the outermost loop is going to be for the second column. The innermost loop is going to be for the first column. So you enter the loop, I is 1. Check, this is true. If this is true, go down. J is 1. Check, this is true. Follow the blue arrow, go down. Printf on the screen, the value of j, which is 1, I is 1, and the product is also 1. From this statement, you must go back here to expression 3 in the innermost loop. Increment j by 1, so j is now 2. Check again, this is true. Print again, j is now 2, I is still 1, so you get the product is 2. Keep on looping for all values of j. I remains at the previous value, the same value. Once this is false, go back here to expression 3 in the outermost loop. So increment I, go to expression 2, which is true. Start all over again with j equal to 1 and keep on looping for all values of j 1 to 12. The only way to exit the loop is for this to be expression 2 in the outermost loop is to be false. Once this is false, out of the loop. So you run this program, this is the output. Values of j is going to be in the first column, I in the second column. This is the product, I times j or j times I. In the next lecture, we go to chapter 12, where you see how to read from a file and how to write to a file. Thank you.